right. So this is going to be our first foray into probability and statistics. So um, we could have done a variety of things to wrap up the semester here, but I felt like probability and statistics is something that many of you can expect to encounter later on down the line. And so this is what we're going to focus on for these last couple weeks, and then we'll have some time to kind of do grade corrections and that sort of thing those last couple weeks for those of you that are still a little bit off where you'd like to be. So that being said, let's hop into z-score and bell curves, right? So I'm imagining that at some point in your life, many of you guys have heard of a bell curve, and what a bell curve is just it's a probability tool, and we'll talk later in the week. It's also called a normal distribution, right? And so what it looks like is just like a bell. It looks something like this, right? And that's kind of my drawing of it. And I don't expect drawings to be perfect, and that's okay. And what a bell curve is right in the middle of the bell curve. So right here, we have the average or the mean, right? So we'll say average or mean. And I think it's going to be beneficial for you guys to think of it as average or mean. If you progress into statistics and the formulas that I'll give you today, use mu, the Greek letter mu, for average or mean, and that is just like a U with tails on either side. And that's what I'm going to write into the formula. But the key is that you guys understand that mu is truly just the average, right? So if we all take a test, right, the average score is all of the tests added up, divided by the number of people in the class, and that gives us out our average score. That's all mu is, okay? And so the the idea here is that we're looking at how close values are to the average, okay? And the tool that we use to do that is called a z-score, right? The second piece of what we need for the z-score is what we'll call the standard deviation, okay? And the standard deviation is just a number that allows us to talk about how close or far we are to the mean. And so we're not going to talk about how to calculate a standard deviation. You'll always be given the standard deviation, at least in this class. But the standard deviation is essentially how close or far away am I to the mean, right? If I'm 3 standard deviations away, then I'm pretty far from the mean. But if I'm 1 standard deviation away, then I'm pretty close, right? And so z-score takes that into account. It takes the mean into account, and it says, okay, well, on a standardized bell curve, here's how close you are to the mean, okay? So let's look. We would choose to plot these standard deviations on like this. So for example, that would be one standard deviation. You'll often see it abbreviated SD, and the formula is going to use a what is that, a sigma? I think it's a sigma, but it looks like an O with a little tail. So that's 1 standard deviation away, right? And then twice that distance would be 2 standard deviations away and 3 standard deviations away. And you could do the same in the other direction. 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away, right? And on the bell curve, we're not really going to plot anything bigger than 3 standard deviations. We kind of have rules for what goes on within those first 3 standard deviations. Beyond that, standard deviation is designed to capture 99.7% of the data within those 3 standard deviations. So the data that it happens outside of that is kind of data that we choose to kind of forget about, or at least not count as a portion of the data that really influences our decision making, right? So there's the rough breakdown of the bell curve, which is also the normal distribution, which we'll further talk about on later in the week. But the math portion, or the calculation portion, if you will, of what we're going to do today is called a z-score. Okay, and so z-score is going to be represented by z. And to find a z-score, we take a value. So that value we're going to call x. Okay, and there's nothing really special about x. All x is a value. So if the average on a test is 68, right, that's the average. And then maybe the x is your score, you got a 72. So a little bit above average, you got a 72. That would be the x that we choose to use, right? Next, we will subtract away the mean. So we'll use yellow for the mean. And recall that the mean, we're going to use mu because that's what you would potentially see later on. But when you see mu, just think average, think mean. Right, so I'm taking x, I'm subtracting the mean, and then to standardize it, I divide by whatever my standard deviation is. That's mu. Okay, so mean and standard deviation. Okay, so what we're going to be doing is we're going to be finding z-scores, and then we're just going to be coloring in a bell curve to show what values are above or below, right? And so with our bell curves, at least for today, we're going to assume that after we've taken the z-score, that our mean is going to be 0. So the average is 0, and our standard deviation will just be 1. Okay, that's not always going to be the case, but for simplicity's sake, let's assume that today. So let's look at our first example. Okay, so the average, the mean, is going to be, let's say, 45. Okay, or maybe let's how about we just use our test example that we were previously talking about, right? So the average test score was a 68. The standard deviation of the tests is, I don't know, let's go with 4. Maybe let's go 3. Right? So the sigma, the standard deviation, that measure of variance is 3, which maybe doesn't mean a whole lot to you, other than, you know, we can expect that 99% of that data is falling within 3 standard deviations on the positive side and on the negative side, right? And then you got a 72, let's say, and we want to find the z-score, and then we want, so that's 72%, and we want to see how many people, or we want to shade for all the people that have got a score less than you. So we'll say we'll shade for less than 72%, right? So let's see what that looks like. So to find the z-score, I want to take my x, which was 72. I want to subtract my average, or my mean, which was 68. And I want to divide by the sigma, or the standard deviation. And so now I'm going to simplify. 72 divided by 68, just going to be 4. And 4 divided by 3 is going to be 1.3, repeating. So essentially, we'll think of it as 1.33. So a z-score that's nice to have 2 decimal places. and we'll talk more about that on later in the week, right? So my z-score is now 1.33. Now that I've found the z-score, I'm going to recall that I wanted to assume that my mean was going to be 0 and my standard deviation would be 1. So let's draw a little bell curve and kind of plot what this looks like on there. So bell curve, and my mean, I'm assuming, was 0. And then my standard deviations were 1, 2, and 3, and -1, -2, and -3. Okay, and so we want to find all of the values, or we want to shade the portion of the bell curve that is less than that 72% that you got. So the z-score of the 72% that you got was 1.33. So that's a little bit more than 1, right? Now if we shade to the right, what we're shading is all of the scores that were higher than that 72% that you got. If we wanted to shade all the scores that are less than that 72%, then we shade all the scores that are less than, and we'll learn how to figure out what this means more later in the week. But we can shade this portion and say that these are all the scores that got a score less than you, right? And maybe we want to find something out about them. But for now, we figured out what the z-score was and shaded less than that. Make sense? Okay. Let's do one more. So we'll call this example 2. Okay. So this time, I'm going to say that our average is 5.7 and our variation 0.6, and our x value we will choose to be, I don't know, let's go with 4.8. Okay, so first step, I'm going to find the z-score. I'm going to do I'm going to normalize. That's the kind of the phrase that we would use. I want to normalize this data. So to find the z-score, I take my x value, okay, which I was going to write and apparently not. My x value, which was 4.8. I'm going to subtract mu, which was 5.7. And I'm going to divide by the standard deviation, 0.6. Okay, now I simplify. So in the numerator, 4.8 minus 5.7 would be negative 0.9. So we can have negative. Don't worry about that. And I'll divide by 0.6. If I'm not mistaken, this will be negative 1.5, but I'm going to check. That's correct. And so now our z-score is negative 1.50, right? And so let's say that I wanted to find, I wanted to shade for all the values that were greater than 4.8. Right, so to do that, I draw my bell curve. So bell curve, this one's a little bit lumpier, and that's all right. I assumed that my mean was 0. I've got 3 standard deviations on either side. 1, oopsies. 1, 2, 3. 1, 2, 3. Negative 1. Right? So I was at negative 1.5. So I go to negative 1.5, negative 1, negative 2. It's somewhere in between those two. And I wanted all the values greater than negative 1.5. So I'm going to shade all the values that were greater than negative 1.5. okay? So what we're doing today is laying the groundwork to talk about normal distributions later in the week. And so it's important that we're able to successfully calculate z-scores and kind of look at a bell curve and shade a proper area, okay? Now in the homework, the first 7 questions, you're shading greater than or less than. For the last 3, you're actually going to find 2 z-scores and then shade the area between those values or something to that effect, right? So maybe I would say on this problem, I want the values between 4.8 and I don't know, 5.9, right? And then I would shade that portion of the graph after I found that z-score. So it doesn't have to just be greater than or less than. We can talk about between as well. And so you'll get a chance to practice with that on the homework. If you have additional questions, remember you can always reach out to me through my email, and hope you guys are all doing well.